Hello and welcome to The Only Way is Open Source. In this short video, I shall be walking through how to set up and operate as a local certificate authority using openssl. For those interested, I have linked a downloadable PDF version of this guide in the description below. So without further ado, let's get started. As most of the commands are going to require us to have elevated privileges, I'm going to switch user. Make sure that you have the openssl toolkit installed. So we're just going to grab this command and copy and paste it straight in. Next, we want to set up a directory structure for our certificate authorities files and configurations. mkdir /root/ca. Next, let's change to our newly created directory. So cd /root/ca. And now within here we want to make the following subdirectories. Still in this location, we want to create an index.txt file, and this will be used to track all the issued certificates. So just grab this command. We now want to create a serial file. This will contain the number 1234. Each time a certificate is issued by the certificate authority, the number will automatically increment. So just paste it in. And lastly, we want to secure the CA directory. So we want to change mode to 600. The owner, who is root in this instance, will have read and write permissions. Group and others will have no access. Next, we want to modify the openssl.cnf. This is the master configuration file, and this defines various settings that control how certificates, keys, and other cryptographic elements are created, signed, and processed. It does contain predefined sections, and anything in green are our edits, anything in orange are additions. So to edit the openssl.cnf, we'll grab this command, paste it in. So if we scroll down to the CA default section, which is here, we want to change the first line, the directory, and we want to change this to our location for our CA directory. So it was /root/ca. We then want to scroll down to the policy match section. Which is here. And we just want to tweak this a bit. So we want to change this to supplied, optional, supplied, optional, supplied, and optional. We then want to go down to the policy anything section, and the only thing we want to change here is the common name to optional. And then we want to go down to the rec distinguished name section. So here, okay. So here we want to change the country name. As we see, we're going to set it to GB. So scroll down. We then want to state our province name. So we'll get rid of some state. In this case, I'm making up a state called fake state. The locality name we want to provide, and we want to provide a default for this. So we want to add the new line locality name with capital N _ default. We then want to tab to be in line with the equals above. Press equals, space, and type in our locality name, Arius-on-C. We then want to go down to the organisation name. We want to change this. My organisation is not called Internet Widgets. Scroll down further. Below common name max, I want to add another entry called common name _ default. And again, just be mindful of the capitalisation, equals, and this is the fully qualified domain name of my CA server. So in this case, ca-server.tawios.net. And then lastly, I need to add another entry called email address underscore default tab across equals the email address I want to automatically assign is this. And that's it. As I've finished, I'm going to press Ctrl X, and it's going to prompt me to save. Press Y and enter. We need to actually generate a private key for the certificate authority. So to keep things neat and tidy, we're going to change to the private directory we created in our CA folder. We can copy and paste the commands, or we can type them out. I now want to generate an encrypted private key for the certificate authority. This is going to be called cakey.pem. It's going to have a size of 4096 bits, and we are using the AES 256 encryption. So we'll grab this command, quite a big one, paste it in. When I press enter, because we're creating an encrypted private key, it's going to ask me to create a passphrase for it. So I'm going to use TOWIOS22, enter. That's then going to ask me again, so TOWIOS22. I now want to create a self-signed root certificate for the certificate authority. So I'll grab this rather long command. For those interested, I've provided a breakdown as to what the command means in the description. When I press enter, it's then going to ask me for the passphrase of the cakey.pem file that we created previously. So it's TOWIOS22. And it's now going to prompt me to enter information to include in the self-signed CA certificate. So it uses information from our previously adapted openssl.cnf file. I'm happy with the defaults, so I'm going to leave it as GB. I'm going to leave the province name, leave the locality, leave the organisation name. Not going to add anything there. Yep, that is the common name. Email address is fine. Okay. And then lastly, we can verify the CA cert PEM file. It is optional, but it gives us an insight as to what it actually looks like in a human readable format. So you should have, in theory, something that looks not too dissimilar to this. We now want to create a certificate sign request for a target machine. So still on the CA server, again, just to keep things neat and tidy, we want to change to our requests directory. I now want to generate an unencrypted private key, and the reason for this is that this target machine is a web server, and if at any point I restart my web server, I do not want it to prompt me for the passphrase. So I want to generate a key called mysite-key.pem, press enter. I'm then going to use that key to create a certificate sign request. And again, it's going to pull information from the openssl.cnf file. In this instance, yes, I do want it to be GB, but we are going to change a couple of things as we go through it. I'm going to change the province to Kent, change the locality name to Canterbury. I'm going to change the company name to My Site. I'm not going to put anything in the unit name. I'm going to change the common name, as my fully qualified domain name is actually webserver.local.local. I'm going to just leave the email address as it is. I'm not going to enter a challenge password. I'm not going to enter in an optional company name. Next, we want to sign the target machine's certificate sign request. So, ensuring that we're in the request directory, we're going to sign the CSR. So using this command, I want the output to essentially produce a certificate called mysite-cert.crt, and that is the certificate that we want. So press enter. It's now asking for the passphrase from our key for our certificate authority. So remember, way back then we put in a passphrase of TOWIOS22. So it's happy, and it's now asking me, do I really want to sign the certificate? Well, yes, I do. So I'm going to press Y and enter. Do I want to commit? Yes. And that's it. We have a signed certificate. To show you, if I just do ls, we can see our files there. We've .crt file, which is our certificate. We've got the .pem, which is our key, and we've got the .csr, which is our certificate sign request. And lastly, because we are on the certificate authority machine, we just want to tidy it up a bit. We don't want all those files in that one place. So we're going to move the certificate file to the certs folder, and we're going to move the key to the private folder. And lastly, configure your target machine to use SSL. What you want to do is move 3 core files. So we have the certificate authority's public certificate, so the crt.pem that we previously created. This will need to go onto the target machine in /etc/ssl/certs. This is the root CA certificate, and it will ultimately allow the target machine to trust anything that certificate authority has signed. We then want to ensure that our certificate for our target machine, so the mysite-cert.crt, so the certificate for this web server, is also placed in the certs folder. And then we want to ensure that the key for the target machine is placed into /etc/ssl/private, because that ultimately is paired with the target machine certificate, and it's used to decrypt data and establish secure communications. So make sure on your target machine those 3 files that we previously created are moved over to your target machine into these locations.